Module 1, Lesson 2, Graphs of Quadratic Functions. In this lesson, we're going to interpret the graph of a non-linear relationship between two quantities, x and y, and we're going to look at that relationship between the physical quantities by looking at a graph. Turning your workbook to page 6. Example 2. The table below gives the area of a square with sides of whole number lengths. We're going to plot the points in the table on the graph and draw the curve that goes through the points. First thing though, you have a mistake in your table right here under x is 1. The sides are x and the area is y. Your y value has a 2 right there and it needs to be a 1. So please make sure you change that. Otherwise your graph won't look correct. Okay, so on our x-axis, on the x-axis, we're going to plot the side values, and on the y-axis, we're going to be plotting the area. So let's plot these points. We've got the point 0, 0, and then the point 1, 1, 2, 4, so that's over 2, up 4, 3, 9, so that's over 3, up 9. And then there's the point 4, 16, which that point would be off the graph. Over 4, up 16. So that would be like way up here. Be way off the graph. And then, as the direction said, we're going to make a smooth curve through those points. It would end up looking something like this. Okay, it can't be a straight line because the rate from one point to the next, it's not the same. Okay, so from like point 1 to point 2 here, the distance is not the same amount. It gets wider and wider spread out as you go up the curve. So that's why it's not the same. Or that's why it's a curve as opposed to a line. Okay, now it says on the same graph, reflect the curve across the y-axis. And then what you get is the graph of a quadratic function. Okay, so let's act like the y-axis here, this line right here, the y-axis, we're going to act like that's a mirror line and we're going to reflect those points. Okay, so since the 0, 0 is on the y-axis, it would be the exact same point. But this point right here, for example, it would be 1 away on the opposite side, so right here. And this point is 2 away from the y-axis, so its reflection would be 2 away on the opposite side of the y-axis. And then this point right here, it's 3 away from the y-axis, so we would go 3 away on the opposite side of the y-axis. So we're making like a mirror. And then this point that I just kind of pretended, it's way off the graph at 16, it would be over here on the negative 4 side, way off the graph. And that would be the other half of the curve. And what we get here is called a quadratic graph. And so that's a quadratic graph, or a looked at those a little bit. They were the U shape in the last book, quadratic function, or it's also called a parabola. That's the name of that U shape. And they can open up like this one does, or they can open down if they're flipped over. And then the line that's in the middle, so this line right here in the middle, that's actually called the axis of symmetry. Okay, so that line right there is called the axis of symmetry. All parabolas have them. And if you find half of the parabola, you can use the axis of symmetry to find the other half of the parabola, or quadratic function, or u. Okay, moving on. We're going to use some more equations to find some more parabolas. Whenever a quadratic function always has an x squared in it. Okay, so that's one characteristic. Whenever you have an x squared, that equals a quadratic function, or a parabola, for the shape. So x squared in a function means that it's a quadratic function. Okay, so we're going to do some input-output values, and specifically we're going to use the numbers -2, -1, 0, 1, and 2. So let's plug those numbers in, and to do that, you're just replacing your x's. So as far as my work goes, I would be plugging those numbers in place of x. Now you gotta make sure whenever you have parentheses, or whenever you have negative numbers with an x squared, you have to put it in parentheses. So I would say -2 squared plus 2. And then -1 squared plus 2. Okay, and then 0 plus 2, 1 squared plus 2, and then 2 squared plus 2. Now technically you don't need to have your positive numbers or 0 in parentheses. So 1 squared plus 2 and 2 squared plus 2. And the answers are going to be our outputs. Okay, so I'm going to grab my calculator and I'm going to put those numbers in. So I've got -2 squared plus 2. And the first answer is 6. -1 squared plus 2. And you should be doing this on your calculator too to make sure you understand. And then 0 squared, which 0 squared is just 0, so plus 2. I won't be surprised when the answer comes out to just 2. Okay, so there's my first three answers. So 6, 3, and 2. And then my last two answers. 1 squared plus 2. And 2 squared plus 2. I got 3 and 6. And you'll see some of the numbers repeated, and there's a reason for that. It's the whole idea of that axis of symmetry and how some of the numbers are the same on each side of what we call, I should have labeled this point down here is what we call the vertex. It's the center point. So once you find out where the vertex is, you'll see that the point starts to repeat. Okay, so let's plot these points. So the first point has -2, +6, and then -1, +3, 0, 2, and then now they start to repeat, +1 and 3, and 2 and 6. And then we can make that U shape, just like that. So that means that the y-axis is the axis of symmetry, and the point 0, 2 right here, that's the vertex point. They didn't ask us that, but I just want to tell you a little bit of the characteristics of the parabola. Okay, so that's our first one. We're going to go to number 4, which for you guys is actually on the next page. Here, we're actually going to use the same numbers. -2 for x, -1, 0, 1, and 2. Now this one is 3 times x squared. So as far as my work goes, I'll say 3, and then parentheses, wherever you're replacing the x, that's where you put the parentheses, -2, and then squared. Notice my squared's on the outside. And then 3 times -1 squared, and then 3. In this case, since we're multiplying, we want to keep the parentheses on all of them, or you'd want to add a times symbol in there, but you have to have parentheses around negative numbers, so you might as well keep going with parentheses. 3 times 0 squared, 3 times 1 squared, and 3 times 2 squared. Okay, so I'm going to grab my calculator, and I'm going to start filling in. So 3 times -2, and then squared, equals. First answer is 12. 3 times -1, and then squared. And that one's 3. 3 times 0 is 0. Even though it's being squared, 0 squared is still 0. So that one's going to come out to 0. There's my first 3 answers. I didn't want them to go away from me, so I'm going to write them down. So it was 12. 3 and 0. Okay, now to do the positive 1 and the positive 2. So 3. Oops, I'm still on the pen. I've got writing all over my calculator. Okay, 3 times 1 squared is 3, and 3 times 2 squared. And that's 12. So 3 and 12 are my last 2 answers. Oh no. Oh no, what did it do? I didn't turn my pen back on. So 3 and 12. So you can see that those 2 repeated again. Okay, so now to plot our points. So we've got -2, positive 12. This actually has 11 dots, so the 12th dot would be just above. And then -1, positive 3, 0, 0. And then when they start to repeat, you know that's where the symmetry is coming into play. So 1 and 3, and 2 and 12. Okay, so here's our parabola, or our U shape, to that one. Okay, this is actually the last one that we're going to work on together. We're going to use the same x values again. So -2, -1, 0, 1, and positive 2. Okay, so this is what it's going to look like this time for the work. You should have a work column in each of your problems that you do on your homework today. So 2 times -2 squared minus 5. And then 2 times -1 squared minus 5. 2 times 0 squared minus 5. 2 times 1 squared minus 5. And 2 times 2 squared minus 5. Again, the parentheses are important on this one because it serves 2 purposes. One is for multiplication, and 2, when you're squaring those negatives, you have to have them in parentheses. But even with the positives, I need them there so that the calculator knows the 2 and the 1 well, the 1 squared is being multiplied by the 2. Okay, so 2, and then parentheses, my -2, it's going to be squared, and then it's going to be multiplied by the 2, and then subtracted by 5. And that answers 3. And then 2 times -1 squared. So what it's doing order of operation wise is it's first squaring, exponents are first, then it's multiplying, and then it's subtracting 5. The calculator knows all those order of operations, so it's doing it completely. And that one came out to -3. So we had 3 and -3 so far. Okay, so now for 0, 2, oh, I keep writing on my calculator. Here we go. 2 times 0 squared. So it's doing 0 squared first, that's 0, and then multiplied by 2. Well, 0 times 2 is still 2, or still 0, excuse me. And then it's subtracting 5. 0 take away 5 is -5. Okay, and then the next one, 2 times 1 squared. So it's doing 1 squared. 1 times 1 is 1. Then multiplying by 2, which is 2. And then subtracting 5. -3. So it looks like my numbers are starting to repeat again. So if that one came out to -3 and the numbers are starting to repeat, does anybody have a guess of what the next number would be? I think I know. Let's see. 2 times 2 squared. Order of operations is exponents first, so that means it's doing 2 times 2, which is 4, times the next 2, which is 8, and then subtract 5. 8 subtract 5 is 3. If you guessed 3, you are correct. Okay, this middle 0, 5 would be the vertex, and then these two came out to be the same, and then these two came out to be the same. Okay, plotting the points. So I have the first point is -2, so left 2, up 3. And then -1, backwards, left 1, down 3. And then 0, -5, so stay on the y-axis, down 5. Now I'm going to start doing the reflected points. So +1, down 3. See, it's symmetric here. And then +2, +3. And that point and this point here are symmetric. And there's our U shape. Okay, and that's today's lesson. Not too bad, I hope. Not too long either, 18 minutes.